This is the second part of a 4-part series looking at the neurological examination. If you haven't watched the first video, which was the introduction to this session, I would strongly encourage you to look at that so that what follows will make sense. The next step we're going to look into is correlating neuroanatomy with the physical signs that you're going to find during the neurological examination. And you'll notice for this session that I'll be going back and forth between the neuroanatomy and the physical signs. Just stick with me as I go through this step by step. When you're doing your peripheral nervous system exam, you'll notice that there is a system that you must follow and that you must do the same steps in the same sequence all the time so that you don't miss out things or you don't miss out steps. So usually we'll start this examination with inspecting how the patient looks like, how the limb looks like, and seeing if there are any clues that we can pick up on inspection. From there, we'll move on to examining the tone and seeing if there is any reduction or increase in the muscle tone. We examine the power, going step by step, working through the upper limbs and the lower limbs to see if there's any change in the power. We then examine the reflexes. These are the deep tendon reflexes, and with this as well, you go step by step, working through the upper limbs and down the lower limbs. We then examine the sensation, and we'll go into sensation in detail, the different modalities of sensation that you have to test, and with those as well, you have to go step by step, making sure you're not missing any level in the upper or lower limbs. And then we examine for coordination, and this mainly is assessing the function of the cerebellum. So for the purposes of this session, I'm going to be focusing on the tone, power, reflexes, and sensation, and seeing how the neuroanatomy that we're talking about correlates to the things that we find when we examine these 4 areas in the neurological examination. I want to move step further. Going back to the diagram that we started with, I want to go a step further in the classification of the neurological system. So you can classify the system further into central nervous system and the peripheral nervous system. And your central nervous system is made up of your brain and your spinal cord. So any problem occurring in the spinal cord or in the brain, you would classify that as a problem in your central nervous system. And the way information is carried in the spinal cord or in the brain, it's carried through your nerves, and usually it will be a series of nerves, one passing information to the other until it gets to the destination. So you can go a step further and talk about neurons, which is another word that means a nerve. So neurons that found in the central nervous system are called upper motor neurons. And the peripheral nervous system is beginning from just outside your spinal cord all the way through the nerve root. If the nerve bifurcates or if the nerve splits and goes down into small nerve fibers until it reaches its destination, and that could be an organ or it could be a limb. So anything happening outside the spinal cord, from just outside, the spinal cord to the end organ, this bit will be called the peripheral nervous system. And nerves or neurons in the peripheral nervous system will be called lower motor neurons. So that helps you because there's a pattern to the presentation of these problems. So problems in the central nervous system or problems affecting upper motor neurons have got a particular presentation. And problems in the peripheral nervous system or problems that are affecting the lower motor neurons have got a specific presentation. I'm going to go through this again to make it even more clearer. So we've got two main parts of the nervous system, the central nervous system and the peripheral nervous system. Out of the peripheral nervous system, you will get an upper motor neuron. Out of the peripheral nervous system, you'll get a lower motor neuron. From upper motor neurons, you get upper motor neuron problems or an upper motor neuron lesion. From the lower motor neuron, you will get lower motor neuron lesions. And the presentation of an upper motor neuron lesion is very specific. So when you examine the patient, you might find things like increased tone, increased reflexes, and reduced power. When you examine a patient with a lower motor neuron lesion, you will find reduced tone, you will find reduced or absent reflexes, and you will find reduced power. So just starting with the pattern that you find in the patient, you can work your way up and decide where the problem is, which goes back to localization. Moving on, I want to talk about a part that many students find very confusing, and I also found this confusing as a student. And this was about the tracts or spinal cord, central nervous system tracts. So a tract, in its most basic definition, is a bundle of nerves that carrying the same function. So this group of nerves all does the same job, and the brain or the central nervous system and the neurological system as a whole is very organized. So if you look at the way the nerves are grouped, you'll find that nerves that carry the same job or that do the same job will travel together, and there's no confusion in the way these nerves travel. Another way that I find it easier to understand a tract is to think about it as a column. And I've used this picture of columns to illustrate. So imagine that this column only has one job, or the nerves that are traveling in this column only have one job. I'll zoom into that picture further. When we want to look at the tracts in detail, we find that it's a lot easier if we look at the spinal cord in cross-section, so that we cut through this column and look inside and see how these tracts are organized. This next picture creates anxiety in some students, brings back a lot of bad memories of not understanding neuroanatomy. And don't be terrified at this point. So just remember where we started from. We started from talking about columns. And this is your spinal cord in cross-section. It's your columns in cross-section so that we can see what's going on inside. And these different groups of nerves are your tracts. They're carrying the same basic function. Ignore the labels outside. I'm only going to focus on a few tracts so that you don't get lost for purposes of this session. The other thing about tracts is their naming. So there is a conventional way of naming tracts, and this will apply to most tracts. Not all of them, but most of the tracts. And it's important to understand this because it helps you to figure out where these nerves are coming from and where they're going. So as a convention, when naming tracts, the first half or the first part of the name refers to the origin of that tract, and the last bit of the name refers to the destination or where that tract ends. So for example, if you have a tract that's starting from the brain cortex and going into the spinal cord, you will call that a cortical spinal tract. If you have a tract that's starting from the spinal cord and going to the thalamus in the brain, you will end up with a spinal thalamic tract. There are certain tracts that don't follow this naming rule. So for example, the dorsal column is a tract, but you will see from the name we can't really figure out where it's starting from and where it's going to. But we can still get some information about the nature of this tract if we just look at the meaning of the words that make up its name. So dorsal refers to something that's at the back or something that's posterior. And column, in this session, we've been using that word interchangeably with tracts or a bundle. So a dorsal column would therefore be a posterior tract or a tract that we find at the back of the spinal cord. Another thing that I want to point out about tracts is tracts will have a direction depending where the information is coming from and being taken to. So you will have ascending tracts, which are tracts that are carrying information from the periphery going up into the spinal cord into the brain. And you can also have a descending tract, which is a tract that's starting from the brain, carrying information down into the spinal cord and going into the peripheries or the organs. So as an example of that, we can look at an example of a descending tract. So remember we talked about the corticospinal tract. So this is a tract that's starting from the cortex going into the spinal cord, and its direction is downwards. The information that's being carried is being carried from the brain downwards into the spinal cord. And that's your corticospinal tract, which is a descending tract. An example of an ascending tract would be the spinothalamic tract. So this is a tract that's carrying information from your spinal cord going up into your thalamus, which is a part which you find in the brain.